Thanks for coming in on an off day.
No problem. Pleasure.
Hey, look, oh, wow. So this is not a small.
I've been doing it for 20 years.
Boy,
Aside from where I live.
so cool. But where are you?
That's a long story. I'm supposed to be in the Bay Area. My manager's listening. Yeah.
Before COVID, you were there?
No. I used to live up there.
Okay.
Yeah. And then after
We just dropped an announcement.
Now I'm staying here.
Oh,
That's actually become an issue recently. It's yeah.
yeah, everyone's on the side of this time.
I thought they were.
3 days a week and pretty much the whole day.
You want me to drop this, right?
So, yes. Right. So I'm looking at changing, actually changing. Or I guess they're a little stressful these days. And not continue with it.
All right, well,
We'll
we have
see.
options here.
Yeah. I quite frankly, I enjoy it more. I know it's one of those questions too. Of course, we're just, yeah. We're just waiting.
But we just wrote on your table.
It's good to know if you, good to get a pulse of what you find fulfilling.
We'll be in touch. Do we just need two?
Yep.
Okay, cool.
You also have people on Zoom or what?
We're really expecting it.
I should have, should have wondered if it's switch here. But I can only hear my right ear.
You sure you want to hear what
I think we have two very different perspectives on this. That should be interesting.
Yeah, cloud is I'm programming languages for
okay.
I back in cloud through some research that we did.
Oh, I see. All right.
So you'll probably have more of a finger on the pulse of it.
Probably start at 5:05.
Sure, no problem. Usually, so when I'm not, so when I used to only teach one quarter, I'd only be in LA that quarter. And I'd actually lived in the mountains the rest of the year.
Like where?
Near Mammoth.
Oh, wow. Okay.
Yeah, so I still, live up there in the summer, but
Okay, you got a good thing. Wow. I didn't say I've never been up there this whole time I've been here.
well, if you're from Washington, you're not missing.
Oh, no, it's beautiful, especially well, at least, but also like compared to me going to like Big Bear or something.
Oh yeah, definitely.
Are you from LA?
Yeah, grew up here. I had a stint in the Bay Area where I lived up there for a little while. My team right now is actually in Washington, and I'm supposed to be based in the Bay Area, so I'm kind of flying all over.
So you're going back and forth?
I go back and forth to the Bay Area and to Washington.
Oh, wow, okay. So I guess you got on that other stuff. There's this whole new process for these things, but hopefully it will be relatively lightweight.
Oh, okay, yeah.
I think you got some email about it.
I did, yes. So, thank you. Yeah,
I think it's pretty lightweight, but it's like because there's a new way of doing contracts where you get like a one course employment, then like a 1 year, then a
1 year, then it's
3
year. Yeah, I mean it's 3 until the.
And then you're like sort of 10 years. That's what. Yeah. I don't think anyone's seen that. You know, if you want to this
I can make one for you.
It's originally a thing on like if you with remote, you just get on those salaries.
Yeah, I wish they would give me that option. I know Airbnb allows fully remote. I like their data. And there's a pharmaceutical company in Thousand Oaks called Amgen.
Yeah, no,
Yeah, they also are hiring software engineers remotely.
okay, but you also moved there, so that would
Yeah.
be
Yeah. So we'll see. It's a very uncertain time.
You're not looking at questions.
Okay, so I guess we're gonna get started now. Okay, so thank you guys for coming to this research panel. We got two amazing guests here. It's Professor Milstein and Professor Rosario. And yeah, they're gonna be talking a little bit about their research and what they do and how they got into their current academic careers. Let's see if you could. Okay, so this is going to be a general overview. So we're going to have these two amazing people introduce themselves and discuss their current research and all the cool stuff they're working on. Then we're going to have like a general Q&A and then some closing announcements. And then for the final hour from 6 to 7, we're going to be like, kind of mingling around. Quick disclaimer, we only have this room from 5 to 6 because room booking here is amazing. Yeah, so we're probably just going to like move out to the patio and like, talk and stuff. But yeah, so if you want to
Okay, sure.
you don't have to follow this slide.
Okay, yeah, it's weird seeing this
Yeah.
slide and me behind me, but I'm Todd. I've been a professor in this department for 20 years, and I'm the department chair right now. I've been the chair for a year and a half. And my main research area is actually programming languages and software verification. So designing programming languages and proving that software has the security and reliability and performance properties that you want from it. That's really what I do. So I think my connection to the cloud, which we'll talk about maybe later, and maybe why I was suggested, is because some of what I've been doing in the last 10 years is applying programming languages ideas to computer networks. So the same kinds of techniques we can do to get security and reliability of general software, you can actually use to ensure kind of reliability of big data center networks and kind of the physical infrastructure that underlies the cloud. And so that's what I've been spending a lot of my time on. So we can talk more about that later, I guess. Yeah.
Everyone, I'm Ryan. I teach CS 143 here and newly CS 144 next quarter. I've been a lecturer in the department for 8 years, since not 8 years, 2018, whatever the math is there, 6, 7 years. And I lecture part-time. My full-time job right now is I work in Google Cloud, hence the connection here. And prior to working at Google and at UCLA, I worked at Facebook for a few years doing machine learning, also at Amazon for a short period. I had a contract or consulting gig at Riot Games for a little bit as well. So I've been doing a variety of different things, most of it involving distributed machine learning, and now working in Google Cloud as well as teaching. So I'm happy to be here. My type of research is not the pure academic research that involves writing a lot of papers and whatnot. It's more industry level research where it's part of my job, but not the main part of my job. So I'm looking forward. You have two people here that have very different research experiences that I think will be interesting to you.
Okay, so now we're gonna move on to the questions. So you are encouraged to participate as actively as possible. So if at any time they're going over something and you're like, wait, I'm really interested in that. I want to know more. You can just like raise your hand and ask a question, or you can just like type it out in the Discord channel. So yeah, you're highly encouraged to just ask some questions directly. Okay, so for our first question, so how did you first get into pursuing computer science?
Sure. I'm going to try to condense this. I always loved computers. I always was interested in learning how to program, but was not good at it when I was in high school. I tried. I was also not great at math back then. Things have changed. When I joined the math major at UCLA, I had to take a programming class, and I was very interested in that programming class and was fascinated by it. So I basically continuing to learn programming on my own. When it came to pick a PhD program, I actually chose statistics. I couldn't decide between stats and CS. And I felt like stats was an easier road given the math major. So I went with that. But I quickly got bored with it. And I was working in a lab, it used to be called SENS. It was an embedded network sensing lab, IoT type stuff. and I was surrounded by computer science majors, and I just loved what they were talking about. I said, maybe I'm mature enough now to handle it. So a lot of my friends that were there took this class about web information management with Professor John Cho. They talked about how a search engine works, how a recommendation system works, all of that fun stuff. And we had to create a project where we had to basically crawl a website, extract data, and do some research with it. So I crawled Facebook and learned a lot about distributed systems because I had to use multiple nodes in order to crawl Facebook. I'm not going to say what year it was, but there's probably only about 10,000 people on the UCLA network. That's when I was hooked. I said, you know what, maybe I need to continue with computer science here. And that's basically what I did. I went ahead and finished the PhD in stats, but ended up getting a master's in CS and ended up in the computer science department as well. So it was a very very pivotal in my career. Without him, I would not be in CS. I don't think.
Wow, that's good. You're teaching this class.
Yeah.
So I didn't have, maybe just because I'm old, but I didn't have a computer when I was growing up. Computers weren't really in my mind at all. I like math, and when I got to college, I thought I would be a math major, maybe a chemistry major or something. And I just kind of took the intro programming course my sophomore year just to see what it was all about. But then I was just like hooked from there. I just really, kind of just that was it. And I just decided, okay, that's what I want to do. And I just you know, kept taking courses, switched my major. I did some research as an undergraduate. I TA'd also as an undergraduate. So I got a lot of kind of good experience that then led me to further steps like graduate school. So
what classes and topics stood out to you the most when you were undergrad?
So even though my research area is machine learning and now also databases or data management systems, I think the most fascinating class I took was 118, the networking class. It was very accessible to me because there's a lot of analogies to human communication. All we know is how we communicate. So to implement a network, let's just mimic humans communicating. So to me, it made computer science very accessible to me. It wasn't this foreign, it's hard, but it wasn't this foreign thing. Like it wasn't rocket science. It was just think about how you would communicate with a friend or with another person. When they don't listen to you, you repeat what you say, just like a retransmit in networks and whatnot. And that's kind of how I think I'm successful in CS is being able to draw analogies to everything, to human communication. So to me, that class was fascinating to me. If I had to go back and get another PhD, I'd probably do it in networking.
well, maybe it's obvious because I do programming languages research now, but programming languages, I guess here would be 131, but in my college it was a different number. But I think programming languages are exciting because when you learn to program, you learn in one particular language, and then you find out that there are actually many different ways to communicate with the computer and get it to do what you want. And some of them are radically different from one another. And it gives you different ways to think about what computation is and different ways to solve problems. So I think programming languages for me was kind of like the hook, and seeing a new language that's structured in a different way than other languages, or that can do something in a really clever or clean or beautiful way that other things can't do is just like really kind of a powerful and exciting thing. So.
Okay, so how did you discover what you wanted to specialize in? It could have been a class, it could have been a plug or something. So how did you get into like the cloud computing area of research?
So I guess I'll go first. Well, so my main area of research is programming languages, and the way I got interested in that, I mean, when I went to grad school for a PhD, and I was doing different things. I was looking at databases as a research area. I was looking at AI as a research area. AI wasn't, that popular at that time, the way it is now. And then one of the professors where I was in grad school had his own programming language. And when I saw it and played around with it, I thought it was like the coolest thing I'd ever seen. And so then I just decided that I wanted to go and work with him. And so then that led to the work that I ended up doing my PhD dissertation on. The cloud or kind of networking stuff really came from a friend of mine who actually was in grad school with me, but we didn't work together then, but he did a PhD in networking, and he went to work for Microsoft research. They have a research division, the way that many companies have a research division. and he asked me a couple of questions. Like once I just saw him at a conference and he asked me whether I thought whether I thought certain programming language techniques could solve this problem that he had in networking. And that led to a collaboration that we've now had going on for more than 15 years, including starting a company and all kinds of other things.
So I'll stick with the cloud aspect of this. Was there a question?
Sorry, I was curious, like, what was the language that's
Yeah, I'm curious, Steve.
was it like is it like
You probably haven't heard of it, but it's called Cecil. You can look it up, Cecil. So it's not like a widely used language. It's a very academic language. But what it did for me that I thought was really interesting was, um, like if you take 131, you'll probably learn about functional programming languages, and separately you'll learn about object-oriented languages. Like functional language would be like OCaml or Haskell or Lisp, and then object-oriented language like Java or C++. And they seem very different from each other. And what this language did was in a very, very simple way, get to the heart of like have a very simple core language that would let you sort of program in either style and get the best of both worlds from those and kind of see how they relate to each other, as opposed to thinking of them as two completely different paradigms. So.
sorry.
No problem. So I'll stick with the cloud aspect of this. So in that web information management class, as I'm developing this crawler Facebook, I'm using multiple machines that were in our research lab and building the distributed system myself, which is very, very difficult. It's not it's fun, but it's very frustrating. And so I thought to myself, there's got to be a better way to do this. And at that time, so probably around 2005 is when AWS started offering cloud computing or somewhere around there. So I started looking into that and realizing all of the stuff that I implemented was already available in AWS. The problem is I had to pay for it, but I ended up learning a lot about it and ended up using it even for my dissertation research because I had a very, very large 100 gigabyte data or something. So I forced myself to learn how to use AWS in order to do processing. And now I work in distributed systems for machine learning at Google, but that's kind of how it started, which is my own curiosity.
I guess you guys already went over this, so we can go to the next one. Okay, so what made you choose academia and like your research over more standard industry like something like SWE role?
I guess you didn't.
Well, so I think this is going to be fascinating. So, um, so, so I kind of did make this decision. I originally just decided to go into industry, but I love teaching, so I also teach. So what was the question? What made you choose academia? So that was a conscious decision to choose both. I could have just chosen to do one or the other. And so I really enjoy interacting with students. I find that I actually learn a lot more from teaching than I even do in my day job. I really like my day job, but I feel like I'm always programming for a purpose, not just to make money for a company, but for a purpose to get something done and to also help students. So I kind of did consciously choose, but I chose both in a sense. But I'm not a research professor, so I didn't choose to spend my entire working day basically doing research and teaching.
So you chose academia because you like teaching, like about the industry.
What do I like about the industry? I'll be honest, a lot of it's a paycheck, but I do like solving very challenging problems. That's part of the role of being a software engineer in industry. If I could do it all over again, I may have gone the more academic route, actually.
Can I answer that? Sure. Well, I think I mentioned before that I started doing research as an undergraduate, and so I was lucky to have some research experiences and got really excited about that. And so because I had that experience as an undergrad, I kind of decided that I wanted to pursue that path and went to grad school instead of going to industry and kind of just kept going on that path. So, yeah.
What like so you said like you first started getting into research. Yeah, do you remember like which topics that you first got into, like what made you start like yeah, like I want to see like what researching this is about, and then it like propelled you to like okay, yeah, I want to keep doing this to like grad school and beyond.
Yeah, I mean, actually, what's funny is that I think like the topic it was some database project, and it came about because I just had a class with a professor, asked like usually what happens here too is I asked him, hey, do you have any research projects? he had this thing available. I didn't know anything about databases or even care about them or whatever, but you know, and that didn't become really part of anything I ended up doing. It was more just the experience of it's a different way of working than what you work in when you're doing classes or when you're software development, and none of them are better or worse than others. It's just that there's this, when you're in a class, you're usually solving problems that we know have a solution, and you're learning the method to solve those things, but we know how to solve them. Software engineering, usually, also there's a clear kind of product goal, and there often are problems along the way where you need to figure out, but sort of the goal is clear, maybe, or at least roughly. I think one thing that's interesting about the research side is that when you start off, you don't even necessarily know what the goal is. So you're actually trying to find the goal as much as you're trying to find the solution. You're trying to find out what problem you're solving and why is it an interesting problem to solve, and then you figure out how do you solve that problem. And so it's a different kind of, and it's and it was like, and to see kind of, I was working with grad students who knew so much more than I did, and I was kind of seeing the way that they thought about problems and just being exposed to ideas and things that I wasn't seeing in my courses. And it was, I don't think my role was very big. I think I just kind of like did what they told me to do and did it okay, but I didn't even necessarily even understand what I was doing or whatever. But I could just see the process that they were going through and see the kind of things that they were thinking about, and that was kind of exciting to me. So
Yeah, the ambiguity is definitely different in research versus an industry role. You can have that ambiguity as a software engineer, but you have to make sure you choose the right area that you're working in the right team so that you can thrive in that ambiguity and kind of not just be thrown out to the wolves. Whereas in research, you get to pick your area essentially and pick what types of ambiguity you're willing to deal with.
Okay, so you two went over why you chose academia over like industry. So why did you choose to be involved as a professor or a lecturer at UCLA specifically over anywhere else?
I see him looking at me, so I'll start. This was actually not planned. It kind of fell into my lap. And a trend that I see among lecturers, that's kind of what happens. There's not a long recruitment process, say, as there is with tenure track and whatnot. I had left my PhD program for a little bit to work in industry. And when I came back to do my final oral defense and whatnot, I fell in love with UCLA again. So I really don't want to leave here. So I thought maybe I should get the teaching position somewhere. I didn't run into a lot of luck, so I kind of just put it in the back of my head, so I'm going to industry. When I went into my final oral defense, Professor Cho is on my committee, and he's asking me a lot of random questions that have nothing to do with my research, but have to do with a class I took with him. I remember, and if you've never sat in on a defense before, I encourage you to do so. I actually think that they're intense. They're a little bit, yeah, there's hard questions asked and whatnot. And at one point, I asked him, "Why are you asking me this? This has nothing to do with my research." And he just said, "You just answer the question, please." So we went through this, and at the end, when I passed, he came up to me and said, "Look, I'm switching research areas or something like that, and I'm looking for somebody that could maybe take over 143 or 144." And I thought, wow, this was not part of my plan. Let me think about it. I thought about it, and we went through the process of whatnot, and I decided to do it. And so it kind of fell in my lap, and I'm really happy that it fell into my lap because it was very random.
Kind of related to that. Do you know what the typical process of putting a lecturer would be if it doesn't happen like that?
Yeah, so I applied and whatnot. There's a process for that. There's positions posted on each department's website, usually for tenure track and or for a lecturer or teaching professor, and you can apply through that process. And you can apply, for example, if you're graduating from UCLA with a PhD, you could probably go to a small liberal arts college, another private school. USC hires a lot of CS PhDs. UCLA sometimes does. It just depends on what openings are available, but there's always a process on the university's website to do that.
And I also think it's gotten a lot more over the last few years, especially in computer science. It's gotten a lot more similar to how other faculty, like research faculty, are hired, just because of the demand for computer science education. Every school needs lots of lectures. So it used to be the case that you'd have a few, and they were mostly local people working in industry or your alums or who were stated around the area or whatever, and you found them in this kind of that kind of way. But I think more and more you're seeing national searches for great teaching faculty because because everybody needs great teaching faculty. So yeah.
It's just in my case, it was kind of random, but yeah, there is a process.
So I came here because I had no ties to UCLA or even LA, but I was in grad school in Seattle and I did a kind of nationwide search for professor jobs and I interviewed at lots of places and got a bunch of offers. And I think UCLA was the most attractive for various reasons. I mean, I think one thing that was, I mean, there were a lot of just normally good things like just the quality of the students, the quality of my colleagues and things. But one thing that was unusual was that at the time, UCLA had nobody in my general area of kind of programming languages, and they knew they needed to change that. And so they actually did like a cluster hire. So they hired 4 of us in 1 year in the same area. So Professor Paulsberg, who you might know, he actually joined the same year as me, and a couple others who aren't here anymore. But the interesting thing was that they had all said yes, and I was the last one. So I knew they were all coming, and I knew them personally. I knew Professor Paulsberg personally. One of the other ones, I had written a paper with him. We had worked together. So it was kind of not just a random group of people, but a group of people that I knew really well, had already worked with and stuff. And so that was really exciting.
When you said like you mentioned like you were applying institutions, so is that basically like right after you earned your PhD or?
Yeah, and so that's what's happening now here too. I mean, we just had a candidate today. They have talks in this room, and like we had a robotics candidate today from Berkeley, but like we have candidates coming from all over the country. Some are from Canada, some are from Europe, and so when you finish, you kind of, I mean, some people might have specific constraints or where geographic constraints or otherwise, but a lot of people will just do a search overall because you don't know where there's openings in your research area. You don't know, it's hard to know where you're going to like where, how many offers you're going to get and things like that. So,
Wait, what you sort of best at on doing programming languages, or we sort of like applying to be more open with like
as a professor,
yeah.
Well, once you got your PhD, you kind of have to, even if you want to pivot to some other area, like you've done a PhD, you've spent 6 years on some topic, and you're an expert in that area. That's the area in which you kind of have to like that's the area that you're an expert in. So that's the only area you can become a professor. Like you're not gonna like if I do a PhD in programming languages, I can't really credibly go and say, okay, I want you to hire me, but as an AI faculty. But at the same time, once you get hired, nobody tells you what research to do, and people can and do switch research areas all the time. And so, like, yeah, I mean, I'm doing some collaborations in AI, I'm doing some collaborations in networking and things that have nothing to do with programming languages, but I just mean like when you first come out to go for a job, it's based on sort of the record of expertise you've built up. And so you can't really say at that point, like, oh, consider me for something else. Yeah.
So, what excites you about your current fields of research? Could be something cool you found recently, or maybe something you've been interested in all throughout your many years of research.
So at Google, one of the things that we're doing research on, and we're actually writing a paper right now about this. So we have research scientists that basically do research full time. So they often move back and forth, sometimes with tenure track roles, or they work part time as a professor, part time at Google or whatnot. My team's not like that. We're software engineers, but some of us do research. And what we're researching right now is basically how to effectively power AI workloads on the cloud. So I'm in Google Cloud. There's a system called Kubernetes that also runs on Google Cloud. It's called the Google Kubernetes Engine. And what we're trying to do right now is trying to power AI workloads that have billions and even trillions of parameters. So for large language models like Gemini, or even Chat, we obviously don't do Chat GPT, but they have a similar infrastructure over at OpenAI to do that. And it's extremely challenging because we have different kinds of chips that we have to work with, and not all of us are experts at what those chips do. So things like GPUs, graphic processing units that you may use for a video game or graphics, and TPUs, which are these little, kind of like GPUs, but they're specific to Google's cloud and they enable a lot of different kinds of research that GPUs don't. So trying to figure out all of this and how these different architectures work is probably the most challenging thing that we're dealing with right now. And how do we shove it into the product so that users can use it? So that's basically what our paper is about. It's going to be about how we schedule GPUs and TPUs on GKE in order to power these large workloads.
So I mean, there's a lot that I'm excited about, but I would say like bigger picture, the thing that's most exciting for me in the last couple of years is that all this kind of stuff I've been working on for a while on verifying data center networks, large computer networks has really become real and sort of gone from being sort of research publications and toy demos to sort of tools that major companies can and are using to kind of to ensure the security and reliability of their networks. So that's an exciting transformation to see and to go through.
Okay, so what are some challenges being worked on right now in cloud computing or like in your current research?
I'll let you take that one because I kind of explained it in my previous answer.
Well, I'd say cloud computing, and at least so what the area related to cloud computing that I work on is computer networks. And so, like someone said, the cloud is just another term for someone else's computer. Right? And so, like when you're saying the cloud, there's actually some physical devices, lots of them sitting somewhere, and your data has to get over there. Your computation has to get over there. It has to be, failure tolerant. So if something fails, it fails over to another machine. So computer networks play a huge role in that. And when you when you use AWS, they give you this like service level agreement that guarantees you that your failure will be that it'll be 99.99% reliable. Someone has to actually ensure that that's the case, and that's really what our tools are doing. And so they're actually living at the level of the physical network infrastructure that is that your AWS workloads are running on, and proactively finding security vulnerabilities, proactively finding situations where you're going to lose connectivity before you lose the connectivity. There are a lot of huge challenges there, like just the scale of a network the size of like a cloud, like a public, like Google's cloud or AWS is so large that a lot of techniques that you might to make sure that it's working properly, a lot of techniques you could use in like a research paper and show on a small network just completely fail when you have like a worldwide network of that size. So how do you take, for example, like a lot of the tools that we've done originally, they assume you give me the whole network and we analyze it. And that kind of works like on the UCLA network. And in fact, we did that like early on in our research. We got access to all the configuration files for all the network devices in the UCLA network. And we could do that. But you can't do that. There's no way to analyze the whole network of like all Google Cloud. Like like it's just way too big. You would never finish that analysis in like your lifetime. And so one of the big challenges is how do you sort of break up a large network into pieces so that you can analyze it and still be able to tell you with high fidelity what's happening in the network, what kinds of security vulnerabilities it has, what kinds of other challenges it has. And that's one of the big challenges that I'm working on right now.
Yeah, I agree.
Yeah, so what is a typical day of research like? How much is it programming? And do you ever feel stuck in your work and how do you deal with that?
So for me, it's like 95% of my day is programming as a software engineer. On the side, we're writing papers about some of the stuff that we're working with, powering really big AI models on Kubernetes and our distributed system and this massive, massive networking cloud. So it's kind of it's a side thing that we do. So I would say we maybe spend our big coding and also developing data that we use to create and implement experiments in order to get that data for the paper. So even though we are writing a paper, 95% of the work is getting the data and running the experiments for that paper. The writing is kind of, I don't want to say it's an afterthought, but it's probably the easier part of the process because we've done all the hard work. So then do we ever get stuck? Oh, all the time, constantly get stuck, probably once a day. Oftentimes it's something involving distributed architecture and race conditions. It was not my strong suit starting this role. It still isn't, but trying to debug them is extremely difficult on a massive cloud system. So yes, I get stuck all the time. We get stuck all
What
the
do
time.
you
Want to cry sometimes. No, usually we're able to talk to other. What's nice about working in a large company like Google is there's an expert for everything. So go to somebody more senior, go to somebody on a different team or a site reliability engineer that might be able to explain, is something going wrong in the network? Is that why you're experiencing these problems? Like a lot of packet loss or something. So there's always somebody to go to, but having to develop the evidence and the data about what the problem is really, really important. You can't just say the code doesn't work. And I think you all know that as well when you're trying to debug something. You have to collect your evidence. Here, there's a lot more evidence to collect, and it could take days, sometimes weeks, to collect that evidence and figure out what's going on.
So typical. Oh.
So are there ever situations where like you're the most senior expert on the topic and there's no one else that you can ask?
Right. So right now, so because we're looking at AI, there's only a couple of us in this org that have AI experience. So I'm one of them, and there's one fellow who's a little bit more senior than me. So we are sometimes the go-to for certain questions about AI, and that can be stressful at times. Coming from my previous team was a lot of people that studied AI. Usually, though, there's somebody in the company or even just outside, there's in an adjacent work area that's much more knowledgeable than me. That's one of the things that I love about my company. There are a lot of people, the majority, 99.9% of the people I feel are smarter than me or more experienced. There's a lot of people I can go to that will know the answer or can give me tips. And then I have to then implement those tips if they don't know the straight out answer.
Um, so I think typical research day really depends. I think for me, a lot of what I do is advising students on their research. So we're collaborating in the sense that I'm giving high level advice, and usually I like to have my hands in at least one of the projects, like either doing some programming for it or doing some, if it's a more theoretical thing, helping with some of the formalizations and proofs that are part of it. But usually what's happening is that, students are leading the work, and I'm really helping them to get unstuck or helping them to figure out what the next steps are. And it really depends on research. In a research project, there's really different phases. There's an early phase where you don't even know what you're working on and you're really just trying to explore. And there it can feel like you're stuck all the time. But you really are making progress. You just have to have faith that you are. You're just kind of like blindly following around, following your nose and seeing where it leads. And usually it leads to somewhere interesting, but it can be hard to know how long that process is going to take. Once you've found kind of your direction, it becomes more like it becomes more clear how to make progress and what the next steps are. And then there's the phase where you've done the work and you're writing up a paper, and then that's a whole other part where I'm helping students, write papers or giving them feedback on drafts of papers and things like that. So it's kind of a mix of different things.
So, how do you come up with topics to conduct research or write papers in?
It really depends. A lot of it is for me is it's often like serendipitous in the sense that like there's no one way. Like this project that we're doing now with networking came about because a friend of mine just asked me, "Hey, could you do this?" And sometimes that's how it works, just talking to other people, especially people in other subfields of computer science. You hear what their problems are, and you see if you can help solve those problems. Sometimes I read a paper and I feel like, oh, they completely didn't solve that problem in the right way, and I think there's a better way to solve that problem or something like that. So it really it's a lot just like being out there in the world, like seeing what else is going on, talking to other people. That's how you get ideas of what are important problems. Because the problem is not just that you can solve the problem; it's that it has to be an important problem, or else nobody cares. And the only way you can really know if it's an important problem is to kind of be in the community, talking to other people, reading what other people are doing, thinking, and interacting with others.
Yeah, so for me, when I was in grad school, how I came up with my topic was I was very interested in natural language processing, and there wasn't a lot of research at that time about how to work with small text, tweets, basically, and how to classify them and how to learn from them.
in the machine learning model and whatnot. So what I did was a little bit out there, though I think a lot of research topics are like this. I tried to apply a statistical technique that worked on numbers to words, basically. So there's a technique called the bootstrap where you just resample numbers in order to develop a distribution of a particular phenomenon when you have a small sample. I decided we do the same thing with words. Can I take a small text and just resample these words according to some distribution? So maybe I have a very large vocabulary, and my tweet contains 5 words. Can I take each of these words and pick a new word that represents that word that's similar to it in some kind of vector space and kind of augment this tweet and make it bigger so that there's more words in this tweet, and then use a standard classifier to try to classify the text in the tweet. So this was a very off the wall idea. My advisor thought it was a very off the wall idea. So did my committee, but I was able to prove that it worked. So it was really just being passionate about and obsessed with this little algorithm and stats and applying it to in a different context. And I think a lot of people do that, but there's really no one way to come up with what you do research. And sometimes it's I read the paper, I didn't like how they do it, or I think I could do better, or I think they failed to consider this particular part of the topic, and then you go and research that and write a paper about it. That's another method that people often use that I've seen when I'm reading papers.
You say it was off the wall. Does that mean like your advisor like was encouraging you not to do it? Or
So my advisor was a very, very open-minded guy who believed very strange things. So when he heard this, John DeLeu, he used to be the chair of the stats department. It became Yin Yang Wu, though, after he retired. And so he was just very open-minded. He said, okay, if this is something that you think will work, I'll support it. And I don't think a lot of advisors would do that. They'd be like, don't do this. You're going down a rabbit hole, or you're going to be here for 10 years. That may have happened anyway, but for a different reason. So he was just very supportive, and I'm very thankful for that support because I was able to graduate.
Okay, so what would you say is the biggest accomplishment in your career, and why was it so important?
I think for me, I always kind of said, I mean, it's definitely the biggest impact I've had as students. Kind of, we had this research project about validating computer networks. We did a startup on it, and it's kind of gotten to the point where now it's being used by sort of major tech companies everywhere. So that's definitely really exciting.
I think for me, it was earlier in my career when I worked at Facebook. A project fell in my lap. My project was basically sentiment analysis for large clients. So people, companies like Walmart and Coca-Cola write big checks to Facebook to give them analytics or give them data about how Facebook users are feeling in aggregate about a particular marketing campaign. So one time, Coca-Cola, they had the Santa Claus, a bear, wears a Santa Claus hat. They changed the color of the hat for some reason. So they ran 2 campaigns, one with the red hat, which is your standard Santa Claus hat, and one with the blue hat. I don't know why they did this, but they did. And they ran a couple of these in different segments, and they wanted to know what the sentiment of different demographics of their fans felt about this different marketing campaign. And my manager had tried doing this, but wasn't successful. He tried training a classifier using an off-the-shelf method for sentiment. I said, well, can we just use something like naive Bayes, very basic statistical model? So I implemented it, and it became the first sentiment analysis system of Facebook. It garnered a ton of attention from a lot of executives. Sheryl Sandberg name dropped my project that I was working on when we were working on it. The attention that I was getting was much larger than I had ever wanted. I was very humble, and it was very uncomfortable at times. But it had a huge impact on the company because now moving forward, after I left, they then went into deep learning models and improving the model that we developed using deep learning. And now I'm sure they're using large language models to improve upon that. But my manager and I were the ones that started this and that actually got it done in the first place, whereas other people had tried and failed. So that makes me pretty proud, even though I'm not at Facebook anymore, or Meta, I should say.
related to that, I don't know if you're allowed to share, but do you remember what the outcome for the different colored hat was?
I don't, but one thing that I tell my class when we talk about this topic, or OLEP it's called, is Paula Dean is this country chef, and she was selling some cookware through Walmart. And at first, it was getting very positive sentiment all over the country. Then she made some kind of racist or insensitive remark while this project was going on. And we could see that the sentiment in the coast was very negative towards her. In the Midwest and the South, it actually became more positive for her. Walmart made her issue an apology despite that, and the sentiment flipped. Now the South and the Midwest were very upset with her and Walmart, and the coast had basically reverted back to how they felt beforehand. So I do know that one.
So, on the opposite note, like, what was kind of the biggest mistake or regret in your career, and what did you learn from that?
Mhm. Oh, um, my biggest mistake or regret is not reading the job description. So I was very into the data scientist role and that going in that direction. When I started out, the data scientist role is basically a software engineering role, which is some machine learning. It matured over time, and companies have no agreement on what a data scientist is still. Because of that, it's declined a little bit, the popularity of the role. When I joined, say, Google, I joined as a data scientist and read the description, but didn't take it seriously. I thought, this is a great software engineering company that builds amazing infrastructure. I'm probably going to be writing a lot of code, which is what I wanted to do at this more mature stage of my career. It wasn't. It was exactly what the description said. You're writing reports, you're writing SQL, which I don't mind, and you're basically talking to technical and non-technical clients. I did have to code in the role, but I wasn't expected to, or wasn't, and I wasn't judged on it. Because of that, I felt like there wasn't a lot of growth within the role, which is why I left into software engineering. But at other companies, their data scientist role is more similar to a software engineer. I just looked at the title only in this case. So that's probably my biggest regret, my biggest mistake. I also regret not jumping around more. Some people say not to do that. Your compensation goes up every time you jump, usually. So it's not as bad as people say it is.
Wait, like jumping around like rules in the same.
No, like leaving your company and then going to another one, staying there for 2 years, and then leaving to go somewhere else. There used to be a big stigma about that. And as long as you can explain why you're doing it for more growth opportunities or whatever, it can be very helpful to you. And my compensation went up every time I switched jobs, including within the company in this case.
Well, I've had the same job for 20 years. I think one of the things that I learned early here as a professor the hard way is about collaborations and being careful about who you collaborate with. It's easy, especially when you're a young faculty member, you'll be like, oh, hey, come and join this grant proposal we're doing on this topic. Like we need a programming languages person or whatever. So you join this project because someone asked you to, and then it gets funded, and now you're on the hook for doing some work that you may not care that much about or be that passionate about. You may not even, you may find out that you don't enjoy working with these people particularly, or you have a different, way of working than them that's not enjoyable. So, I learned to be sort of much more careful about when I kind of commit to collaboration. And so, when I find people that I like to collaborate with, I mean, I have collaborators that I've been working with for 10, 15 years, but then, I'm more careful and sort of not making a big commitment up front. You can try something out and then figure out if it doesn't work or it does work, but it's not a good idea to sort of commit to a 5-year grant up front with people that you don't really know very well. So, and especially not, if the work isn't exciting, it's not worth the money. That's what I've found out. So, that may be true even for your careers too, but definitely it's true for grants. Like it's not, the money is not worth the fact that you're going to spend your time not being excited and fulfilled with what you're doing. So yeah.
Yeah, early on in your career, you may focus on money. I know I did. A little bit later on, work-life balance is very important. Are you learning? Are you growing? Are you interested? Some people don't care. That's fine. If you're not, though, the money becomes a lot less tempting, especially if you can save it.
Skip to it
Sure.
a little bit. Okay. Okay, yeah, just any advice for current undergraduates on wanting to explore more research? Are there any opportunities in your labs or companies?
Um, I think, yeah, you should do it. I mean, unfortunately, we don't have like a central portal where you can just go and see, okay, here are all the opportunities. In part, there's a good reason for that, which is that a lot of times, um, research is different than building a product. It's not like we have a need for X number of developers and Y number of program managers and whatever. It's like we're just doing things that we think are fun and interesting and important. And if the right person comes along, we can find a research project to work on. And if not, and that's okay. And so like it's less about having an existing project and more about like, are you the right person to join, my lab or something like that? And so you really, what that means, unfortunately for you, is you kind of there's no easy way. You've got to just knock on doors, go talk to professors, go to their office hours, But I think that if you're interested in research, then that's really a worthwhile thing to do. I don't know, are people working in research? Some people are. Oh yeah, you're working with them now. Okay, see. Well, we should meet sometime. Yeah, but so sometimes it happens like that. You get an email and someone sounds like, oh, they seem to know this space or they seem motivated and let's see what happens. And um, I'm doing less of that now that I'm the department chair, so my group is kind of a little bit smaller than normally, but most faculty have active research programs and have undergraduates working. So,
Yeah, I think if you're interested in research, please go to grad school. I always encourage at least a master's degree. It's only 2 years of your life. But there's a variety of ways to do research. There's the formal academic research where you're writing papers, presenting at conferences, and that's one avenue that some of you may want to take. There are other avenues. So for example, if you were to continue on, let's say to a PhD, but you don't want to become a professor, you can still become a researcher within industry. So at Google, there's a research scientist position. A lot of them could become tenure track professors, but they decided to do research in industry instead. Some of them hold dual appointments or positions as well. So that's another option available to you. The type of research I do is it's an ancillary part of my job at Google. It's not my main role, but I make time to do it. So it is possible to do that. And doing research at the undergraduate level, things may have changed. So forgive me. You don't necessarily have to get to the point where you write a paper that goes to the best journal in the field or conference. Doing data analysis, writing code for a research lab, I believe is also good, also helps you get into grad school as well. That is considered research, just a different kind. It's a different level of research. So as you continue interested in research, think about those different options. Some of them might suit you more than others.
So you mentioned like doing some masters. I don't know how much you know about like the UCLA STEM program, but I heard like it's very much heavy on like taking classes as opposed to maybe where at another university might be such writing at least. So I don't know if you would recommend trying to go to other universities because these have a certain things.
Yeah, Todd probably has a better answer for this, but I've written a lot of letters for people that go into ESAP, and it does seem like it's a very condensed 1 year, maybe 2 years for some, and it's based on courses. But the master's degree in general has a lot of coursework with it. Unless you do the thesis option, then I think you get out of one or two classes. So really, I think it's up to you about your preference. You can always do a thesis and do a little bit more research, but it does feel very rushed compared to some other universities. There used to be this theory where you shouldn't get your master's before you got your bachelor's. I got all of my degrees at UCLA. I'm not doing research at UCLA. I know somebody who has tenure track with all their degrees at UCLA in another department. But if you're ready to go somewhere else, it could be very valuable to do that.
So I think I'm slightly different in the sense it's not really about ESAP and it's not even about UCLA. I mean, master's degree is not a research degree. So you look at it everywhere, it's taking courses and doing a small project. So I mean, you have an option to do a thesis. You have one option here. You have that option elsewhere. Almost nobody does that option. Almost everybody just because I mean the MS is considered a terminal degree. Like that's like meaning you do an MS and then you're oriented towards going into industry after that, but with like a higher level of responsibility, higher pay than if you just had a bachelor's. It's really not a research degree anywhere. So it's not really about UCLA versus somewhere else. It's just that a master's and PhD are two completely different things with different goals. So yeah.
I actually learned something. I mean, he's right. I mean, a master's degree, you maybe write a thesis. And to me, you're showing the scientific method. You understand the scientific method if you write a thesis. But yes, you're not spending 4 years doing that research. It's very quick. It's a project. It can be helpful. Yeah, so I defer to Todd on whether or not it's a research degree, but the
Well, I should just look at other. It's not true that other places have research, but just look. I mean, they're all. It's sort of all an extension of your bachelor's. It's mostly courses, and then usually some small project. But it's not. It's not going to be different from our program. Well, one thing is ESAP is just the admission process. The program is the program, whether you get your ESAP or not. It's just the MS program. But I just mean like if you look at Stanford's or Berkeley's or whatever, it's the same as ours. It's not any different. So.
One difference I've noticed between ESAP students and non-ESAP students, it's the same degree, obviously, as the ESAP students do seem to want to get out quicker because it's an extension. They consider it an extension or a fifth year.
And they usually can get out quicker because, well, if they've taken courses in the undergrad that they don't need for their undergrad degree, they can apply them towards the master's so they can get out.
Yeah, it feels like the standard masters and people from outside are a little more fluid. It feels like they have a little bit more time. That's just my sense from the students that I've had that were ESAP versus not ESAP, but it's the same degree.
I think we have time for one last question. So, what do you view the future of cloud computing? What areas of it do you think is going to grow or decline? Anything like that? Any new promising fields related that are currently in development?
This is cool, so I'll just say, and maybe other people know, but I went to visit. I got invited to visit Amazon studios in Culver City. So they took over. Well, I think they bought MGM and so they're doing all this crazy. They're moving to like kind of virtual production, so where everything's in the cloud basically. So like you have, well, so they took us. This isn't exactly the cloud, but it's related in the sense. So they took us to this space that has basically screens, like all over displays, all over the ceiling and the sides, and then they can just suddenly, in a very completely realistic way, it looks like you're at the beach or whatever, and so they can film a beach scene for a TV show, all inside there. But then they're actually doing the production in the cloud, so they might send it immediately to someone who's in Chicago, and that person does editing on it immediately, and then they send it to someone else who does the sound for it. And so they're basically moving production, which used to be a very physical thing, into the cloud, so that they can kind of distribute the way they do the work. So I mean, that was just something I saw last week that I thought was really fascinating. So I mean, if that's an indication, maybe many industries are going to be finding opportunities to move their operations into the cloud, which is interesting. Yeah.
So for me, it's not so much on the technical side, but one thing that brings up is who owns the data, and data governance is, I think, something that's going to become a much bigger issue as people move stuff to the cloud. I see there's going to be lots of wars about that. Privacy and government regulations between EU and US are going to become a bigger issue, I think. A lot of companies now are moving to a multi-cloud solution. So they may use AWS and they may also use Google Cloud and maybe Azure as well. They might do this for various reasons. One of them is, for example, if one of the companies shuts down. Right now is a pretty tough time to be in tech. I'm feeling it a lot. We just don't know what's going to happen. So companies are starting to bet on more of a multi-cloud solution. So that's another thing that I think we'll see more of. I think cost is another one. Cost is a big barrier into getting cloud computing. When I was a student, I avoided it for a long time because you're charged like 5 cents an hour. That adds up. Like, is there a catch here? There is no catch, actually. You just have to be very careful. So if you want to, you can get credits as students. to work on AWS and maybe Google Cloud as well. And so I recommend doing that. But trying to help companies optimize how much they're spending for certain things is going to be a big thing because of the barrier to entry. If there's no way to optimize that, companies will just won't use the product because they think they're going to get ripped off.
That's all the time we have for this room. We'll be moving out to the patio if anyone wants to have some snacks or like cookies and stuff. Yeah, but we have to give this room to Speedy.